Now in this section, we're going to look at yet a third method of solving systems of equations. If you'll remember, in the first section, we had the geometric method of graphing the equations. In the second section, we had the substitution method. In this third section, we're going to talk about the addition method of solving these same systems of equations. Let's begin. In this system, we have 3x plus y equals 7, and 5x minus 2y is equal to 8. Now, in this addition method, what we're going to want to do is to simply add these equations vertically so that when we add them together, either the x's drop out or the y's drop out. So what that means is this. For instance, in this system, if this second entry was 2y instead of just y, when I add these equations vertically, 2y plus negative 2y would be 0, and then I would have eliminated the y's, which will allow me to solve for x. So what we're going to do to make this a 2y, remember, since these are equations, we can multiply the equation by any number we choose. In this case, we're going to choose to multiply the top equation by the number 2. So we're going to take this equation, multiply here by 2. Remember, multiply both sides of the equation by 2. So when we do, the resulting equation is 6x 2 times y plus 2y, and that's all equal to, and don't make this mistake because I know it's easy to overlook this, don't forget, multiply both sides of the equation by 2. So on the right-hand side, we have 7 times 2, or 14. Now the second equation is going to remain just as is. We're going to rewrite this as 5x minus 2y is equal to 8. So again, what have I done thus far? I've taken the top equation, multiplied it by 2. Why? Because I noticed that if I had a 2y here, when I add these two equations together vertically, I'll eliminate the y term and have an equation in terms of x only. This will allow me to find the x coordinate. Multiplied this one by 2, left the second equation just as is. Now that we've done that, we're ready to go ahead and add these two equations together. We're going to add vertically 6x plus 5x, 11x. Notice 2y, negative 2y, that's my 0. I've eliminated my y's. Equals, on the right-hand side, I have 14 plus 8, which is 22. Divide both sides by 11, and I find that x is equal to 2. Now that I find my value for x, I still must find my value for y. To do that, I have a couple of choices. I go back up to my two original equations. We can use either one of these, take the value for x, substitute it back into x in either of the two equations you choose, and finally solve for y. Now I'm going to choose in this case to use that top equation because the numbers are smaller, and also because there's no coefficient with y, so once I substitute in x equals 2 in that equation and subtract whatever I get there from both sides of the equation, I'll simply have y. So again, we're going to take this x equals 2, substitute it back, where are we going? Up to that top equation. When I do, I get 3 times 2, which is 6, plus y is equal to 7. Now that I've done that, I'm sure you can see it's very easy to solve for y. Subtract 6 from both sides. I get y is equal to 1. Now again, what does that mean? That means that the ordered pair of my solution is simply 2, 1. Don't get that mixed up. Remember, it's x, y, or in this case, it's 2, 1. What does that mean to me? It means that if I were going to graph these two equations on the same coordinate plane, they would intersect at the point 2, 1. 2, 1 is what they have in common. Again, when there is a solution, to the system, we say that the system is consistent. Consistent means it has a solution. If there was no solution, we would call that system inconsistent. All right, now that we've done that one, and we're pretty good at it, let's try another system of equations. And again, we'll practice using this new method that we just learned called the addition method. So let's take another system. Let's just make it a little bit more challenging. Start over again here. Let's make it 2/3 x. So again, what are we doing? We're throwing in some fractions to make it challenging for ourselves. Equals 3, and the second equation, negative 2x plus y is equal to 6. So take a look at that equation and think to yourself, what's the first thing I'm going to do? Well, probably you're thinking, I want to get rid of those fractions. I hate fractions. Exactly what I'm thinking. So we're going to, remember, use the method to clear the fractions by multiplying both sides of my equation by the LCD. You should be good at this by now. The LCD for this top equation is 12. We'll write that down. LCD 12. Multiplying by 12 times 12 times 12 and times 12, and rewriting this top equation, 3 goes into 12 4 times. 2 times 4 is 8x. 4 goes into 12 3 times. 3 times 3 gives me negative 9y. And finally, on the right-hand side, I have 3 times 12, or 36. Very good. Now that we've gotten rid of our fractions, we're really faced with solving this system of equations. Now remember, this bottom equation was the first one with the fractions cleared out. Now that we've done that, we're going to return to our addition method of solving the system. And that is, we're going to look at this system and try to decide what numbers should I multiply either the equations by, so that when I add them together vertically, either the x's or the y's will cancel out. Well, I see here that if this were a negative 8x instead of a negative 2x, when I add those together, my x's would drop out. Now, another choice is if this were a 9y, when I add them together, the y's would drop out. Which one should we do? It doesn't matter. It's your choice. What I personally normally do is I'll choose the number that uses the smaller factor. So in other words, I'm going to multiply both of this top equation by 4 simply because 4 is less than 9. So I'm going to take this top equation, multiply it by 4. When I do, the resulting equation over here is negative 8x. 4 times y is positive 4y, and that's equal to, and don't forget, multiply both sides of your equation by 4. 4 times 6 gives me 24 on the right-hand side. Now, my second equation, again, I'm going to rewrite it in its form. 8x minus 9y is equal to 36. Notice nothing changed in that second equation. So here we go. We're ready now to add these two equations together vertically. Again, we've achieved our goal, and that is when we add the two equations together, notice negative 8x, positive 8x, we get our zeros. We've eliminated x. 4y and negative 9y gives me negative 5y is equal to 24, and 36 add up to 60. To solve for y, all we have to do is divide both sides of our equation by negative 5. When we do, don't forget we have a positive 60 divided by negative 5, which gives me a negative 12. Be very careful with the signs. I know at this point we're doing a lot of complex operations, but the basics, multiplying a positive by negative, or excuse me, dividing a positive by negative, could get you in trouble if you forget that negative sign. So be very careful. So in this case, we find that y is equal to negative 12. Now again, to solve for x, because remember we need the ordered pair x comma y, not just simply x or y, we're going to take the value we found for y, negative 12, substitute it back into either of the two original equations. Now again, I personally like this top equation better just because the numbers happen to be a little smaller. It doesn't really matter if you like big numbers, take the second, but I like working with smaller numbers, so I'm going to take the negative 12, substitute it in that top equation for y, and then I'm going to solve for x. When I do, rewriting this top equation here gives me negative 2x. In place of y, now I'm going to substitute negative 12, and that's all equal to 6. Solving this equation for x, now we're almost home. Add 12 to both sides. Negative 2x is equal to 12 plus 6, 18. Finally, all we have to do is divide both sides by negative 2. Again, be very, very careful with the basics. Please watch your signs. X is equal to positive 18 divided by negative 2 gives me a negative 9. Now, most students can do this complicated calculation, but then at the very end, because you're sometimes a little overconfident, make small errors and it throws everything off. So be very careful with the sign. Always remember your sign rules. So here we have x, negative 9. So what does this tell us? That we have the ordered pair x comma y. And that's another thing the students make a mistake with. X comma y is the order of the ordered pair. So that's negative 9 comma negative 12. What does that tell me? Once again, if I were to graph the original system of equations, they would cross exactly at this point, negative 9, negative 12. Again, since there is a solution to my system, I say that my system of equations is consistent. Again, if there's no solution, I would call my system inconsistent. I hope you understand this method of addition, practice, and have some fun.